Hello class, this is a video tutorial on Permutations Part 5. In this video we'll be looking at mixed problems. Just like selective criteria, these can vary in style because of all the scenarios that are possible. So for these examples, I want you to consider the problem solving and thought processes demonstrated, and mainly how the problem is modeled or simulated. So don't get too caught in any sort of formulas, but more the ideas and the thought process involved. So here we go. So here we have, in this case, we have 5 girls and 5 boys are to be seated on a circular table. Let's calculate the number of ways they can be seated with the following conditions. We have, first one, no restrictions. In this one, the boys and girls must be alternating. There are 2 couples that want to be seated together. There are a group of 3 boys that want to sit together, and this very long one that we'll get to in time. So you can pause the video at any time and try answer these yourselves. So let's begin. Well, if there are no restrictions for this first one, this just becomes a regular seating question. So by that I mean there are 10 objects in total, and because of the seating arrangements, because of the circular seating arrangement, it's always 10, well, n minus 1 factorial ways to sit n objects in a circle with uniqueness. So there's no repetitions in that one. So in reality, there's just 9 factorial for that one. That's very plain and simple. Here we go for the next one. Boys and girls must alternate. Well, for this one, let's consider, let me copy this actually. Let's consider all the boys and girls first. Now I'll simulate to you the idea of fixing one position. Because of rotation, if we start seating them randomly, because of rotation, it might become identical because of the rotation. So what we do is we pick one position first and we fix it, meaning we make sure that one person definitely sits there and they cannot change again. So let's just pretend that there's a boy sitting here. There's one way we're going to pick that boy to sit there. Now let's consider the condition being put on us. For the boys now to alternate, they have to sit here, 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 or here. How many different ways now are left for a boy to sit here? Well, if one of them are now here, there are 1, 2, 3, 4 ways left to sit another boy in this position. So that's 4 factorial. Oh, sorry, 4. I kind of gave it away. And then for this one, there are 3 left, and then 2 left, and then 1 left. So there are 4 factorial ways to sit the boys separately. And now when we move on to the girls, for this first position, there are 5 ways, and then 4 ways, and then 3, and then 2, and then 1. That there is just 5 factorial. And there we have it. 4 factorial times 5 factorial. So let's go into slightly more difficult positions here. There are 2 couples that want to sit together. So let's simulate this, and let's say that these two are the couples. Now let's think about this. If there are a couple, we're going to group them together. So in essence, we initially had 5 boys and 5 girls. That's 10 objects in total. But now because we're grouping 2 couples together, these two couples are treated as one object each. So in essence, we're down to 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 objects left. And this matches by treating the 10 chairs as if they were 8 chairs. So take a look. That's 1, 2, 3, 4, 5, 6, 7, and 8. So if there are 8 objects left, by following the rule for circular arrangements, if there are 8 objects, there are 7 factorial ways left to arrange the 8 objects. But on top of this, let's pretend that the boy and girl from this couple sit here. Couldn't they also sit like this? Whoops. Couldn't they also sit girl, boy, or boy, girl? So amongst themselves, these two can switch back and forth 2 factorial ways. In actual fact, this couple, let me change my color, this couple here can do the exact same. So that's another 2 factorial way. So we can just simplify this just as 2 factorial squared. And that there is the total number of ways we can arrange the table if there are 2 couples that want to sit together. After seeing that, I want you to give this a go for this question or this example number 4. So a group of 3 boys want to sit together. Pause and give this a go. So if the 3 boys want to sit together, let's pick any 3 boys here. Let's highlight them. Put these 3. So we'll group them together. In essence, that's 1 object. That's 1, 2, 3, 4, 5, 6, 7, 8. We actually have, once again, 8 objects left. And how we'll think of this is that these 3 seats, that's 1, 2, 3, 4, 5, 6, 7, and 8. So if there are 8 objects as a circular arrangement, that's 7 factorial ways to arrange 8 objects in a circle. But amongst themselves, you can switch them around. Well, with 3 objects, how many ways can we order them if there are 3 objects? Well, there are 3 factorial more ways to order them. So in total, if there are a group of 3 boys that want to sit together, this is the total number of ways we can do it in a round table. And there we have it. Now for this last one, this one's rather difficult. You can pause it and watch the next video for this. And yeah, hopefully you get the right idea of how you might model this when I answer it by the next video. So I hope you can see how there's a mixture of all concepts being applied now. We have circular seating arrangements. We have this condition where we make boys and girls alternate. There's a condition here where people have to sit together. There's a different condition here where different sets of groups have to sit together. But overall, I hope you can see how we can simulate the problem just by these small techniques and the way that we modeled it. So I hope to see you in the next video where we answer this last example. Best of luck.